Ah, the Grand Canyon. Awe-inspiring, beautiful, amazing nature in all its glory, but even more than that, it tells us a story about Earth's history. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. So this week we're going to focus on sedimentary rocks. So here is our Grand Canyon, and I guess a big question here is how did it come to look like that? Well, basically we have a series of different events that happen where these layers that you see here, these very important layers, each one of these layers was laid down during a different period of time in the Earth's history. So you see all these layers over here and all these layers over here, and the color of the layers really tells us something. It tells us that there was a different type of environment that was happening during that time period when the sediments were laid down to create these rocks. And that can really tell us a lot about this. After that happened, though, there were all sorts of other processes. You can see in this little animation up in the top left here, this idea of how it came to look like this after these sediments were laid down. It's basically caused by the Colorado River, this guy down here, which has over millions and millions of years has worn away at these rocks. So when we talk about this idea of wearing down rocks, there are two main things that do that on Earth, and the two main things are water, as you see here. We can see these big rocks here, and we can see some smaller size rocks, and of course the sand here is just really, really tiny pieces of rocks, and so the water constantly crashing on these rocks over a long period of time breaks them down into smaller and smaller pieces. Another way that rocks can get broken down into smaller pieces or weathered is by wind. Shapes like this are created by wind weathering. Basically, all of the wind blowing through this, maybe carrying little pieces of sand and stuff like that, kind of acts like sandpaper and over time will wear these rocks down. So I'm going to show you a little video clip here, and I want you to concentrate on this idea of the process that happens here, the process of laying down layers of sediment, that sediment being turned into rocks, and then those rocks being kind of worn away and broken down back into smaller rocks.
Different parts of the park have different surface rocks. Why is this? 350 million years ago, it was under a warm, clear tropical ocean. Skeletons of sea creatures collected in the bottom, in layers. The sea became shallow and silty mud was laid down. Under its weight, the sediments were squeezed into limestone that cracked into vertical joints. Later, rivers washed sand into the sea. The mud hardened into shales, the sand into grit and sandstones. Then layers of younger rock built up on top. Earth movements cracked the whole crust along fault lines, and all this time erosion was shaping an undulating surface. Then in the last few million years, great ice sheets scraped away at the landscape. As they melted, they left sharpened peaks in some places and bare limestone in others. And the meltwater continued to run off over the fault line, cutting deep coves and gorges.
All right, that was relaxing. So I want you to take a look at these four pictures that I have here and think about the idea of the difference of these environments and the different types of things that would be laid down in this sediment, the different types of things that we would later find in rocks that were created by this sediment. So first of all, we want to look at things like this, and this idea of, in this top left picture, we have a stream here, which is carrying and setting down all of this sediment. You can kind of see the size of the sediment here. They're kind of small rocks and things like that, all the way down to the size of sand. Over here, though, we have some different sediment. We can see that the sediment is very fine here. It's really, really small pieces, and that's the kind of thing we tend to see in ponds and swamps and things like that. So you can imagine that if this turned into rock later on, that we would be able to tell what kind of environment was there, because if it's rock that has very small pieces of sediment, well, we know that those kind of things occur in swamps and lakes, so then we can understand that there was probably a swamp or a lake that was there when this sediment was laid down and when those rocks formed. Similar here, you have sand, right? And you also have sand at the bottom of the ocean, but you might expect to find different things in these layers of rock, because if it was at the bottom of the ocean, well, we have some seashells and things like that. If it's in the desert, not so much. So that's why we find stuff like this. This is pretty incredible, right? These are giant 660-pound, 11.5-foot wide oyster shells that were found, of course, wait, 2 miles above sea level in the Andes Mountains? The Andes Mountains, like where Mount Everest is? That's kind of strange. We'll get back to that, but there's a reason for that. But sometimes we do find these things in kind of strange places. But again, it tells us a story. This tells us, well, maybe at some point these Andes Mountains were actually lower down. They weren't so high, and they were under an ocean of water. So, as I said, tells us a story, but sometimes the story takes us in kind of unexpected directions. Like I said, we'll talk about that more. This all makes sense when we talk about plate tectonics and metamorphic rocks and stuff like that. But for now, we're going to stick with sedimentary rocks. So, sedimentary rocks. Sediments are compacted, cemented together, and lithified. And lithified is just a fancy geologic term that means that the stuff that is making the sediments stick together, which basically are mineral crystals, that they are hardened, that they are crystallized and solid. So when we talk about this idea of cementation and lithification, take a look at this, and basically you can see these dark areas here, right? This area that I'm outlining here, all of that stuff, okay? That's basically a grain of sediment, like sand or something like that. And all the stuff in between, those are mineral crystals that all kind of grow in between, just like the salt crystals that we've grown in class. All of those crystals kind of grow in between all of the little pieces of sediment, and they harden, and that's basically what turns sediment into a sedimentary rock. So this sediment comes from weathering, which is basically the breaking down of rock into smaller pieces, like that picture you see there. Erosion, which is the movement of those pieces of rock to a different place, which happens by things like wind and water. And deposition, which is like when you deposit money in a bank, you leave it there. So all of that sediment eventually falls back down and is laid down in the ground. And remember, the key thing is it gets laid down in these horizontal layers. That's a really key feature of sedimentary rocks. So, as I said, sediment can be transported by either wind or water. This is a picture of sediment being deposited in the Amazon Delta. We're seeing this from outer space, and you can see all of this. This is basically the river and land right here. There's sort of some clouds over it, so I know it's kind of hard to tell, but you can see the river kind of widening as it gets to the end, and then you can see all of this mud that's being settled down here in the ocean. So that's a really good example of this idea of sediment. You saw some of that happening in that video clip. Okay, so let's get the parts down here, the steps of making a sedimentary rock. First, we need weathering, which is breaking down the rocks into smaller pieces. Then we need erosion, which is moving those pieces to a different place. We need deposition, which is, again, like depositing money in a bank. You have to put it in, lay it down somewhere. And then we have cementation and lithification. Sedimentary rocks, one of the key features to remember, as I keep saying, is that they are usually layered, and a lot of times fossils are found in the layers of sedimentary rocks. So that's another key feature. You pretty much only find fossils in sedimentary rocks, and I want you to think about why that would be. Think about how igneous rocks form, right, from cooled magma. So obviously any sort of fossil or living thing that was in that in the first place, it's lava, so it would get melted, so we wouldn't really see it in there. And metamorphic rocks go through a process of squishing and moving and things like that, so they a lot of times won't have any fossils in them because they would get broken up in that process. Okay, there are three main types of sedimentary rocks. We have clastic, which basically means they are made of pieces of other rocks. This is mainly what we've been talking about so far, made up of sediments. A main example of that would be sandstone. Another example is shale. Another example is conglomerate. And if you notice in those pictures, the main difference between those things is the size of the sediment that they're made up of. And again, that's really important because that tells us a story of what that area was like when they formed. The second type is going to be called a chemical sedimentary rock, and these form, or what we call precipitate, out of water. This is very similar to what we were doing with our salt crystals. It's basically sediment that is dissolved in water, and that water starts to evaporate, and then it forms rocks out of that. One really good example of this are stalactites and stalagmites. That's how they form. Stalactites are on the ceiling. Think they have to hold on tight to the ceiling. Stalagmites are on the bottom. Basically, the way that these guys form is by water drips through some rock and it picks up some minerals as it goes. You can see some minerals in this picture here. And as it goes through this rock, it picks up some minerals and then it drips off of the ceiling of a cave. And when it drips off of the ceiling of the cave, like you can see in this little mini picture over to the left here, is every little drop of water kind of leaves a little bit of sediment behind that sticks on there, and so it grows and gets bigger and bigger layer after layer over many, many years. The last type is called organic sedimentary rocks, and these are made from the remains of living things. Think seashells in this case. Usually going to be the remains of seashells or possibly the remains of dead plants and animals. So coal would be an example of this. Limestone is another example of this. That's made out of seashells. That's what limestone looks like, and it kind of looks like crushed up seashells all stuck together. So limestone is a sedimentary rock that's made of calcite mainly, and that's its main mineral that's made out of. Some limestone is formed by chemical deposition, like what we were talking about before with the stalactites and the stalagmites, but others can accumulate from seashells falling to the bottom of the sea floor. So basically, you get seashells that die and fall to the sea floor. They get buried by some mud, and then they get kind of squished, and that is another way that we can form these organic sedimentary rocks. This is a good example of it right here. This is the White Cliffs of Dover, and all of that rock that you see there is all limestone. And so what that means is these are just layer upon layer of seashells from dead sea creatures from millions of years ago. All right, so let's see if you can identify these now. Are you ready? So first of all, what type of sedimentary rocks are these? Well, we see pieces of other rocks in there, right? Pieces of other rocks. So what is that? That is a clastic sedimentary rock, right? That's conglomerate, shale, sandstone, and breccia. Those are ones that you should know. And again, it really has a lot to do with the idea of the size and also the shape of the sediment that they're made out of. For example, breccia has really pointy shaped rocks, whereas conglomerate, the rocks tend to be more rounded. And that tells us, again, about the history of that rock and what happened to it over time and what happened to the little pieces that it was made out of. If pieces of rock get push down a river for a long period of time, they kind of break off the sharp edges and they get rounded. And if they don't, they kind of tend to keep those sharp edges. So we can really tell a lot about the history of things by studying these rocks. All right, what are these guys? What classification of sedimentary rock would you say this is? Well, these are organic sedimentary rocks, and you should recognize those as coal and limestone. All right, so we learned today about sedimentary rocks, and we learned that they are caused by weathering, erosion, and deposition, that sediments are compacted, cemented together, and lithified or hardened. And we learned that there are clastic sedimentary rocks that are made of pieces of other rocks. There are chemical sedimentary rocks that form or precipitate out of water. And we learned that there are organic sedimentary rocks which form from the remains of other living things. And we will learn more about that and identify those in class, and I'll see you then.